Assalamualaikum. Today we will doing a step 2, that is radial conduction. So to set up this experiment, first we need to open the water valve. Okay. And then second, we will open the supply. So this will show the temperature, and then open the valve, and then we will check the water outlet. Okay, so the last one, we will open the heater. Okay, so we will adjust until 30 watt. Okay, that's all. Thank you.
Assalamualaikum. For now, I will demonstrate how to install the radial conduction experiment. So first of all, we need to connect the heater socket. And then we install the thermocouple sensor. To install this, we need to look the tag of the sensor. For example, this is number 5. We need to insert at T5. And then we install the water inlet and the water outlet pipe. Alright. And then we secure the radial head conduction platform.
After we set the power to 30 watts, we will wait for the temperature to stabilize, and then we will collect the data. After we collect the data, we are going to increase the power into 40 watts and until 90 watts, and repeat the same step. We are going to wait for the temperature to stabilize, and then record the data. And next, we proceed with the next temperature.
After we finish take all the data from the experiment, we have to shut down all the electric supply. First of all, we shut down the heater, this one, and second one is main supply. We switch off the valve, water valve. And lastly, we close the main supply. That's all for me. Thank you.
Assalamualaikum and very good morning. I am AMIR bin MOHAMMAD, and now I will explain about the result in lab 2, that is radial conduction. So in this experiment, we have 5 different type of power, that is 30, 40, 50, 70 and 70 and 70 and 90. So in this experiment, we had 7 type. There are ambient temperature, that is T1, T2, T3, T4, T5, T6 and T7. So in this experiment, we get the data analysis from the temperature versus ready from T1. So for power 30 watt, we get the temperature that is the highest temperature 312.35 and the lowest temperature that is 301.85. For 40 watt power, the highest temperature is 318.05 and the lowest temperature is 330.15. For power 50 watt, we get the highest temperature that is 326.35 and the lowest temperature that is 307.35. For power 70 watt, we get the temperature highest that is 336.65 and the lowest temperature that is 310.75. So the last one is 90 watt. We get the highest temperature is 343.45 and the lowest temperature is 313.45. So in this experiment, basically we can conclude the relationship between temperature versus ready. That is, if we apply the more power, we will get the higher temperature. But if the ready become highest, the temperature become decrease. That's all from me. Thank you. Assalamualaikum.
Assalamualaikum. My name is ISHAK bin FUZILAH. I will continue to the discussion question. For question 1 is choose one of your set of results. Use the equation in the theory section and the actual value for TT1 at its radial position. Calculate TT2 at its radial position. Use the calculate value to find TT2 and TT3 and continue in this way to find the theoretical value for other thermocouples. Add the theoretical curve to your chart to see how it predicts the result. The data we have choose is power at 30 watt. We use the equation is K equal to W is power times ln R1 over R2 over 2 pi L and T1 minus T2. Since the thermal conductivity obtained is range of material brass 70% copper, which is 109 to 121, we use for the theoretical value. We use the thermal conductivity value is 115 since it's the middle value between 109 and 121. The first equation is T2 equal to T1 minus power times ln R1 over R2 over 2 pi Lk. We get T2 is 308.98 K. For T3 is 306.669 K. T4 is 304.74 K. T5 is 303.23 K. T6 301.995 K. T7 is 300.84 K. This is the comparison between temperature theoretical value and experimental value for power at 30 watt. There is no difference, not much difference between the experiment and theoretical value. This is the graph between theoretical and experimental value. The graph is between temperature time against distance of heat source.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad AFIQ bin Abdul Rahman and I will continue the discussion part. So for question 2, we need to discuss the cause of error between theoretical and experimental data. So the main difference between experimental and theoretical probably is that experimental data is based on actual outcome of the experiment. For example, human error in taking data or parallax error. Also, the unstable temperature due to inconsistent flow of water, which can causing the reading to fluctuate. Next, there might be an instrument error in measuring data. And last one is environmental factor that might affect the result. Next, for conclusion, in radial conduction, the temperature will flow radially from a central heat source through a metal disc in uniform dimensions. Based on the graph generated, we can say that the temperature will decrease as the radius increases. The temperature which is nearer to the heat source is higher than the farthest from the heat source. Since this experiment is using different set of power input, we can say that as the power increase, it will also increase the temperature. And lastly, the insulating material has proven to help us in acquiring a better result as it helps to reduce heat loss due to radiation and convection. Thank you.